Students, in the previous class we have started with the basics of data transfer instruction. Under that we have seen the first instruction, a move, that is MOV instruction. MOV instruction can be used along with different registers, memory, like that. The first example what we have discussed in the previous class holds the data and the data will be stored onto the indirect addressing mode. So here after at means it represents, after at you have to represent the register number. So this register number has to be R0 and R1. Apart from this, if you are writing it as at R2, so the instruction will become invalid. Suppose if you are writing it as MOV, wait 1 minute. If you are writing the instruction, if you are writing the instruction as if you are writing the instruction as MOV at R2, hash 55H, so this particular instruction is invalid. The instruction what I am showing here, it is invalid, and your compile on the assembler will show an error. Why? Because you have used an indirect addressing mode, that is after at you have used, so it is an indirect addressing mode. In indirect addressing mode, after at it is possible only R0 and R1 is applicable. So apart from that, if any other register you are specifying like R2, R3, R4, R5, R6, R7, then that particular instruction will become invalid. And in this data transfer instruction, I have shown the particular example. I'll write one more program, move, I'll write one more program, move at R1, hash 55, okay, hash 55H, it is a hexadecimal data. Now move A, hash 22H, okay, it is also a hexadecimal data. Next I can use MOV, okay, at R0, A. So now line by line execution I will tell. So when your assembler executes the first instruction, here move at R1, hash 55. Here you are using an indirect addressing as well as your hash 55 at R1. So we don't know what is the value of R1. So I can write it as MOV R1, hash 20H. You consider I am writing this particular data. Okay. Sorry. Hash 20H. So when your assembler executes this first instruction, your content of R1 is going to be 22H. Okay. And now move, when it executes your second instruction, that is this particular instruction, when it executes your second instruction at R1, that is now the value of R1 is 22. So inside that 22, that is at this particular location, your 55H will be stored. That is 55 is the data. Now for the first instruction, when you execute the first instruction, at that moment 22 is the data for R1. When you execute your second instruction, 22 is the address for the second instruction. That is 55 is the data, and that 55 data is stored in 22nd location. Okay. Now consider the third one. So third instruction is MOV A, hash 22H. Here the 22 is your data, and when you execute the instruction, the content of accumulator is going to be 22. Okay. Now when it executes the fourth instruction, you consider at R1 here. So when it executes your fourth instruction, MOV at R1, accumulator means what is the content of accumulator here? 22. That 22 will be stored on to your 22nd location. So both address and data is going to be same in this example. Okay, this is how your data transfer instruction works. And also this data transfer instruction can be used with the following this one. You can see over here, move a comma r naught, move a comma r1, r2, r3. So for example, for this the notation will be the content of accumulator, that is source to destination it has to move. So content of r0 will be moved as content of accumulator. For this particular instruction, if you write, it will be content of accumulator will be content of r1 or r2 or r3. So this is how you need to write. Here for the explanation for this particular instruction is the data available in r2 will be moved as the content towards your accumulator, is moved as a content to accumulator. Like this your data transfer instruction works. Also, if you are using accumulator is a 8-bit register. So if you are using R7, it is a valid instruction. For example, if you write like this, move. Okay, I'll write one more instruction. Move a comma hash 01AFH. So like this, if you are writing, the instruction is invalid and it is a error instruction. Why? Because accumulator it is a 8-bit register, whereas the data what you have given in the immediate addressing mode is going to be 16-bit. So it is a invalid. It is not possible for us to transfer the data to the accumulator register. One more example I will tell. So here if you write here MOV DPTR, what DPTR stands for? It is a data pointer and also it is a 16-bit register, comma hash 1111H. Like this, if you are giving some data, it is a valid instruction. Why? Because DPTR it is a 16-bit register and whatever data here you have stored, it is a 16-bit data. So it is a valid instruction. One more instruction is also I will show. The data pointer I can say split as two pointers, that is data pointer low and data pointer high, comma hash 18H. Like this, if I am using some instruction, means it is a valid instruction. Why? Because it is a 8-bit register, that is data pointer it is a 16-bit register which you can make it as two 8-bit register, that is DPL and DPH. So each DPL is 8-bit register and DPH is a 8-bit register. So move DPL comma hash 18 means it is a valid instruction, and this instruction what it does means it move the content 18 to DPL. One more thing I will write, MOV. One more instruction we can see. I'll write MOV DPTR comma accumulator. This is not a valid instruction. Why? Because accumulator is a 8-bit register whereas data pointer is a 16-bit register. You cannot move any 8-bit register to the 16-bit register or 16-bit register to a 8-bit register. So it is a invalid. Whereas if you write the instruction like this, MOV DPL comma accumulator. If you write like this, it is a valid instruction. Why? Because you are moving the content of accumulator as content of data pointer low, that is it is also a 8-bit register and this is also a 8-bit register. So it is a valid instruction. Like this you have different combinations shown over here for this data type, for this data transfer instruction. And one more example also I will show. So whatever here it is mentioned, what the first two things, the first two instruction whatever we have mentioned, it is with respect to your indirect addressing mode. The first 4 one, it is 6. It is your indirect addressing mode. From here to here, you are using indirect addressing mode and immediate addressing. And the next one, next few lines, whatever it is shown over here, like move a comma r0, move a comma r1, move a comma r2, move a comma r3. So till here, it represents your register addressing mode because you are using the register as in the destination. Either you can use like this or you can use like this also, MOV a comma r1. If you use this particular instruction, the content of r1 is stored is moved to accumulator as its content. Okay, it is the representation for this particular instruction. This will be your representation. One more example we can take. It is MOV R1 comma accumulator. So for this particular instruction, what it does, your content of accumulator is moved as content to your R1 register. And as we discussed in the earlier classes, we know how to select the register from your register bank. That is, it depends on your PSW.3 and PSW.4. Based on the bit available in these two, in this PSW, your register bank will be selected, and based on that your register R1, R2, R3, R4, R5, R6, R7 is selected. This is how your data transfer instruction works. Next one, next few lines, like from here to here, you are using your immediate data. That is, whatever data you are giving over here, that will be moved as content to your register. Next one, and this one already we have discussed when we discussed our register addressing mode. Either you can use it from accumulator to register or register to accumulator. So for this, for all these things, the content of accumulator is moved as content to the specified register R. This is how your data transfer instruction works. Next few one, here you are using your RAM addressing. That is, for this it is nothing but when you use a IRAM addressing, the operand bytes of the instruction are stored in reverse order. That is, the instruction containing of bytes 85, 20, 50 means moving the content of internal RAM location 20 to internal RAM location 50, whereas the opposite would be generally pursued. So that is from when you use move IRAM address comma IRAM address, means whatever content you have in 20th location, that will be moved on as a content to 50th location. This is your move instruction. It is one of your data transfer instruction. It copies the content from your destination register to your source register. Okay. This is how your data transfer instruction, and some more examples also I have given over here. So it is nothing but one more example. You can see here some examples. Move A comma R2. What it does in the sense, your content of R2 is moved as content to accumulator. That is, whatever you have in this R2, that will be moved as a content to your accumulator. Second one, when you check move A comma R7 means whatever you have in R7, that will be moved as a content to your accumulator. This is how your instruction will work. Anymore, these are all some of the examples. That is by using your immediate addressing mode, and this is by using direct addressing mode, register addressing mode, and indirect addressing mode. You can kindly go through this all these examples to have an idea. And also we have one more two more examples, like moving the data from to and from the external memory. You can see here MOVX. MOVX is the instruction that makes the data to move from or to the external memory. MOVX A comma at R1. So it from external memory the data will be moved. Here MOVX A comma at DPTR. DPTR will represent 116-bit data. Inside that, for example, I am writing here move DPTR comma hash 1111H. Like this if I am mentioning. So move X A comma at DPTR means at this particular location what data is available, that will be moved on to the accumulator content. That is, it refers to your external memory. Now under this condition, it refers to a external memory for this particular instruction. And one more is also possible. Whatever content you have in the accumulator, that will be moved on to the address specified with the data pointer DPTR. Here it represents your address. This one, it represents your address. Okay. In this, it represents your address, not the data. So whatever data you are using in the accumulator 8-bit data means inside this content, whatever you are loading, it should also be 8-bit, but the address specified has to be 16-bit. So we have like this different types of data transfer instruction, and in the next class I'll tell how to move a code byte to the accumulator. Okay. Thank you, students.